UDK 2018, a security roundup. Big round of applause for Maggie.
Well, welcome back. I'll do my best not to put you to sleep after lunch. My name is Maggie Jauregui. I work for Intel for a team called Platform Armoring and Resiliency. Today we're going to talk a little bit about some of the features included in UDK 2018. A few disclaimers. This isn't an exhaustive list. It's just some of the ones we want to highlight or bring attention to. Not all of these were released this year specifically, but are included in this release as well. One of my favorite quotes is, "There's no such thing as security, only varying degrees of insecurity." So none of these features are meant to be one-size-fits-all or claim to be unhackable. This is part of our continuous effort to improve Tiana Core. All right, so PAR. We are an interesting team at Intel because we are part of the team that develops the core. We're in the same extended team as Vincent, for example. We're also the team that supports ChipSec. Eric over here is the main maintainer. We do our best to, we're also plugged into Intel Bug Bounty, for example. So some of those submissions may be reproduced by us, proposing fixes. So the creation, we try to do a little bit of protecting, detecting, and recovering. You're never done doing security, so this is a continuous process, and these features are examples of what we do to protect and detect security vulnerabilities for our systems. So why firmware? There are some clear advantages to gaining persistence over a platform's firmware. Persistent compromise, stealth, bypassing security features, and the very obvious denial of service. And the reason why we think this has been more and more a thing is because the easier attack vectors that the network has been so overly saturated and hardened that people are now going down the stack to try to do things there. So I think we're in the age of hardening our firmware. Building a threat model. To me, a threat model is the cornerstone of good security. So really knowing what you're trying to protect, what your claims are, what you truly are not claiming, what the attack vectors are, who your attacker is, and again, like security, you're never done with your threat model. It's a living document that you have to maintain. As the ecosystem changes and your attackers change and even your features change, it'll be a changing document for sure. So now mapping the attacks to our platform assets. We have our boot media, runtime firmware that we mostly focus on protecting SMM. The rest we kind of rely on the firmware to protect. And we have our hardware configuration, our logged registers from the core and PCH. So talking a little bit about the evolution of our threat model, there has definitely been a push or a challenge from the community to move that line of physical attack to the left. Yeah. So historically, it was down the middle, where anything that was physical, we don't care. If you have physical access to the system, then you can explode it, hammer it, you can do worse things, you can just steal it. But more and more, and like Trammell mentioned in his keynote, for example, bootguard is all the way down to open chassis, right? So for different features, the line is in a different place. And again, everybody has a different threat model, so this is a fuzzy line, but the trend seems to be to challenge that physical access line. Here's some of our interfaces. We have hardware and firmware. We have our registers for processor and chipset. And then firmware-wise, we have our actual firmware that we care to protect for integrity. And together, it's a complex picture of, we have our assets, we have our attacker model, and we have the never-ending quest to protect, detect, and recover. So this was just a small intro to platform security to segue into a few examples of attacks and features that we've implemented to try to protect against them. Starting with pretty recent attacks that have been presented at Black Hat, DEF CON, recently by Eclipsium. We have an Eclipse site on site. So this is interesting because for the first time, we're seeing remote firmware attacks where you can run arbitrary code on a platform remotely. My favorite was the ASCII calc pop. So yeah, go check out their talks. Basically, the problem here is if you're doing HTTP and not HTTPS, you're vulnerable to spoofing, man-in-the-middle attacks, or denial of services because you can't authenticate and verify that you're actually connected to the server you think you're connected to. So we now have HTTPS boot in Tiano Core. For all of these features, we have the source and the white papers, and this has the getting started guide. We've implemented the TLS protocol. And yeah, one of the other things that we do is we save our secret, our certificate in an authenticated variable, which is protected against replay attacks with timestamps and monotonic counters, and is verified with either the platform key, KK, or DBDBX. Buffer overflows. It's funny to me that I even have to explain this, but basically, when you overwrite the bounds of a buffer, this may be a problem, and it may be exploitable if you overwrite the stack or the heap. This has been a bug as old as time. I just did a quick Google search and found like the first 4 hits on, this has been a thing for a long time and will continue to be a thing. And it's a thing for EFI as well. So we've implemented guard page, and this works for stack and heap. Basically, what we do is we have a non-present guard page. That when it gets overwritten, you get an immediate trigger, page fault exception is immediately triggered. This is better than not having it. It's not a perfect solution. There's large overhead in size, performance. It makes it slow. So it's mainly a debug feature. So making sure that all of your configurations run, and this will fall flat on face, but it would also fall flat on face if we don't have exception handling, and we have limited resources. So this is one of the things that you can use to for forensics and trying to figure out what happened if there was a problem, or just as a debug feature to make sure that your configurations don't cause overflows. DMA attacks. So Crash has been famous, aka, well, they call him Dima. Yeah. So he's famous for ThinkPwn and a lot of backdoors that he implements. More recently, an SMM backdoor that he did through pre-boot DMA. There was a few seconds after PCI devices were enabled and before the system was locked where he could register an SMI handler and do bad things. Ulf Frisk also added this functionality to his PCI leech program, and in response we now have IOMMU. Our implementation is called VTD, and basically we have DMAR tables where we specify what devices have access to. So a device will by default only have access to its own memory. You can tweak it to make sure that opcodes or your devices have access to the things that they need access to. For example, device 1 is assigned to domains A and B. If it tries to access domain C, it will not be able to. We have a good white paper on it. Here's the source to it. Also has its limitations, and it's also not straightforward to set up, and there has to be some time for someone to set up all the resources correctly, but it's there and it can be used. So, yay. All right. And this one is not a hack or an attack per se, but it's a problem that we're trying to address. So whenever there's a bug, how long does it take to create, report it, get it accepted, create a patch for it, have that validated, then send that to OEMs, have them validate it, and then actually have it available for people to choose whether or not they want to update their stuff? How long does that take total? And then we have the WannaCries of the world, right? Like, this is a problem, and we're trying to do something. So we have capsule update, and this is something that we're trying to champion across the industry. It's not new that we do capsule updates. It's not new that they're signed. We've been doing this for years. We actually open sourced this solution since 2016. Part of the motivation for open sourcing it was Min platform, because we wanted to deliver a full open source platform solution, and updates were missing. There's some new things for this recent implementation. We got source and a couple of papers there as well. What else? Yeah, so basically what we do, we have a capsule header that creates an FMP protocol that authenticates the payload, does the update to the flash, and if it succeeds, it registers the GUID to the ESRT table. So what's new? So basically we tried to do it more versatile. We can have the public keys from a vendor. You can have your own public keys in there. We've made it so that you can update only a piece of the firmware and not the whole thing. So you could just update the YAMI, or you could just update a driver. And you could do multiple things, an OS patch, a driver patch, and a firmware patch. Bigger picture, we're trying to make this a push model through LVFS and FWPD. So hopefully, and part of the motivation behind capsule update is that we saw people were implementing them in a whole bunch of ways. So we're trying to standardize the way we do this as an industry. So hopefully this helps. A little bit of promo for the event later. So we don't expect people to just take our solutions and trust it. And so we want to take advantage of the fact that this is open source and invite the community to challenge it, to test it, to tell us if they think we can do something better. We will be here the last 2 days of the con, and it would be great to see you guys there and create your own capsules and see if you can bypass the authentication. We invite people who submit vulnerabilities to the Intel Bug Bounty. So yeah, that should be good. I think that's all we have. Yay. Questions?
So I'm hoping for lots of questions, since we still have a very large audience. Raise your hands. Right. Always the same people.
Perhaps we're not scared of the microphone. Maggie, on the slide about the firmware updates, you said users can enroll their own public keys. Is there some intention that users or computer owners should be able to sign their own firmware updates? Because of course, I would love that, and I think many of us at a open source firmware conference want to be able to do so.
Yeah, we have that functionality as of right now. I don't know if this is just a test feature.
So
but
the problem, and you'll need to use the mic.
oh, Oh, and part of the disclaimer too is I'm not the,
Right, so if you have boot guard, you're going to have many problems. If you don't have boot guard, you may have to do an initial one-time replacement of the firmware so that you can enroll your own FMP drivers and the appropriate keys. But then once you've done that, then you've got the appropriate public keys in your firmware, and then you could start doing signed updates from that point with your keys.
And by one-time replacement, you mean?
Yes, yeah, Mr. Clippy and, yeah, rewrite.
one-time replacement.
More questions?
So if we have chipsec guys here, so I submitted issue about MicroPython support. Yeah. And
Yep.
would like to know what's your take on that.
Over here. It's the Eric show.
You get the main maintainer of chipsec.
So, yeah, we've started the port to support Python 3.4, 3.5. So that will get us to supporting MicroPython. So we're working on that this year and trying to get that worked out. There's going to be a number of bugs. Plus, there's a lot of stupid things that we have to fix, like, switching from the old class model to the new class model, which affects every single, test in the test suite. So needless to say, there are a lot of opportunities for error, and we're going to generate a lot of bugs. So we do have a branch set up for that. We're working on it. We want to get that done this year. And then MicroPython will be, it's Python 3.5, correct?
Yeah, let me
3.5-ish.
3.5-ish. Let me
But-
give a background. For those of you that don't know, there's been a Python 2.7 port for UEFI for quite some time, and the goal of that, I was getting to that. The goal of that was to be able to take Python scripts and execute them at the UEFI shell, because firmware testing is obscure enough as it is without introducing yet another shell script, which we did, yet another C programming style, which we also did. And the QA people don't really know how to do that, but Python's really common in QA and automation environments. So we were supporting that, and chipsec takes advantage of that so they can execute the same scripts in pre-OS environment and OS environment. It's based on Python 2.7. All good things must die. That's got an expiration date of 2020. So we would rather do this work now. I worked on Y2K personally. I don't want to wait till the last minute to do this sort of thing. So instead of porting to the full Python 3 tree, we looked at MicroPython as an alternative because it's Python 3 compliant, but also it's better for a constrained environment like a firmware environment. You're not going to be doing crazy multi-threading in these environments. You really want something that can just get in and execute a small memory footprint. So the MicroPython port is available in EDK2 staging. That's where we put up branches before we consider them to be ready to go to public, like full public. Once that branch has gone through its sort of submission phase, we're going to take the MicroPython submissions and put them in the main MicroPython tree, something we didn't do with the original Python tree. So that'll be part of the main project. We have to work through their process and submission. And then everything else, the testing framework we built around it that has all of the stuff you need, like the accesses, UEFI, and hardware resources, that will remain part of EDK2. And so during that transition, this is when Eric and company are going to be working on getting Python 3 to be the scripting style for the chipsec examples, because you can't just take the Python 2 stuff and run it directly.
So yeah, after we get that Python 3 support done, we're going to go ahead and we'll have to write the OS helper level. And at that point, that should be fairly easy because we're no longer having to build our own stupid version of Python 2 and have all of our hooks in that way. We're actually going to be able to hopefully submit them so that they're built into MicroPython, and you'll be able to grab that and then just run chipsec on top of it without any special modifications. So that's going to start, hopefully we'll start that at the end of this year, and depending on how hard it is to get the OS helper in, we'll get that done hopefully early Q1 of next year.
And also along the lines of chipsec, there's the talk and a workshop on Friday. So be sure to check that out.
Excuse me. So Are you willing to accept for chipsec, for example, some OS help layer for, I don't know, bits or bare metal stuff that can run onto? Okay, that's great.
Please.
Okay, we have 25 minutes. Raise your hands.
You shouldn't be given so much matcha.
Yeah.
It's too much.
I'm curious about the part where you mentioned the HTTPS support in the firmware, where I think you said that the certificate was also included in the firmware in that case. How do you handle certificate revocation in this case?
Certificate replication?
Yeah. Sorry, that's why I'm...
Revocation. Great. Well, yeah, we use the authenticated variable to update it, correct?
Yeah.
The other disclaimer was I didn't implement these features, but
I think the revocation model for HTTPS is different from the one for security, so that.
Mr. Mike?
So the questions about revocation, if you look at the standard model for secure boot, there is there are two databases. There's a DB, which is the list of valid hashes, and then there's a DBX, which you can use for essentially revocation.
right.
That's updated from the OS level, so any OS that has support and you get OS updates for has the ability to publish to DBX. The thing that we would probably have to take offline to check on is if that revocation is also the one that works with HTTPS, because that certificate enrollment process for HTTPS is a little bit different. So that's probably one to, throw that question up on the UDK2 developer mailing list or pass it on to one of us. But the mailing list is always a good place to literally and figuratively hash those things out.
More questions?
I'm a bit astonished that TLS 1.0 and 1.1 are still supported because they have severe flaws. Are there any plans to implement TLS 1.3? Because the RFC was standardized last month.
Question for J1?
Yeah.
For the developers.
So for anything in Tiana Core, if you go to tianacore.org, there is a link to a page on community involvement, and part of that is reporting bugs. So we use Bugzilla for that rather than the GitHub process because it allows us to have a kind of a secure black box for things that fall into please don't zero day us categories. But there's also a feature request category. So TLS 1.3 sounds like a feature request. So that can be thrown in there, and then that way the advantage of doing a feature request through Bugzilla versus emailing one of us or finding us at the reception tonight is that Bugzilla remembers things in the morning, and also it's as long as you're not reporting something that falls under security embargo, it's public, so it's a visible workflow, and everybody gets a chance to talk about it and throw their 2 cents in.
So we all have Wi-Fi. You know what to do right now. Create and +1.
That was sort of the expected answer to TLS 1.3, which is absolutely okay. But the other part of the question, what about TLS 1.0 and 1.1, and especially version negotiation? We have seen a lot of downgrade attacks to web servers and so on. That sounds a little bit dangerous. Can you actually shed some light on that?
But try it. If you can do it, report it, bug bounty. Yeah. Get your CV, get thousands of dollars. Yeah, good idea. I do it.
Okay, little background on me. I studied in Bochum, where the guys are who basically always do the downgrade attacks like Robot recently and stuff. Got a Pony Award. So maybe that's a bit of an encouragement to maybe create a bug request that 1.0 and 1.1 are supported.
Yeah. The other thing is, can we turn those off in the stack? So the nice thing about the network stack in Tiano Core, which you may consider a bad thing about it depending on how many of the buttons you push, it's super modular. So you could probably chuck TLS 1.0 and 1.1 in your configuration and only support TLS 1.2. Now, of course, finding those buttons, well, we're having workshops on Friday and Saturday, but we can, the network stack is extremely well documented. I'm going to give credit to Jaewon and the team in China that did that work. Their wiki documentation of that is very, very good, so I'd probably poke down on that and see if you can figure out, at least on your implementation, how to knock those things out.
Do you know how much the OEMs keep of Tiano Core? Because you said now there are many buttons. How many buttons do they push? Maybe wrong.
You want a real life example? Yeah, there's lots of ways. So, yeah, getting down to the actual OEM and how much of the code that they actually keep and how many buttons they push that are incorrect, there's a lot of the code changes hands a number of times because in most cases we'll do our best to validate a reference platform internally, and that code will go out to OEMs and IBVs and a number of other people, and they're all going to make platform decisions, and it just moves on and on. So the code changes hands. So yeah, it's very possible that someone is going to say, well, I don't like that feature, I don't like the security feature turned on because it makes my life more difficult, or it doesn't allow me to do something that I want my users to do, so they'll turn it off. And it's, between that, they're making feature decisions and they're making decisions about what their customers want. And so, yeah, a lot of things can happen between the beginning and the end.
Again.
While we're discussing, pie in the sky future features, what are your thoughts on eliminating SMM and using some of these So that's, I suppose, question one. And two, making use of some of these new roots of trust that the hardware vendors are starting to implement and proliferate.
Okay, so first part on eliminating SMM. Let's stand up for that one, because I know everyone's going to stare at me intently when we talk about this. Okay, so SMM is one of those things that, it's there in the hardware because some customer needs it for an interesting feature. However, we all know that it's complicated to do right, and it has pitfalls when you do it wrong. It also has some, because you're basically stepping away from the host processor running in like a ring -1, ring -2 kind of situation, it's not ideal from a visibility standpoint. It's hard for the OS to audit what's going on, which can create some problems. So we have a lot of initiatives going on to try to reduce the use of, or in some cases, if you happen to work for a company that designs processors for a living, look at different architectures. Those are longer term solutions, because one day if you just say, we're going to take out SMM, then it impacts the way that a lot of current OS and software assumptions are made, and the way a lot of customer assumptions are made. But it's something that we actively talk about. We're looking at features like, say, runtime variable access, and seeing can we make runtime variable access go away or work differently so that it doesn't have a requirement to do it in SMM because you put so many weird requirements into it that the only good way to implement it is through something like SMM or another side channel or back channel. Saying side channel in this room is kind of dangerous. I wasn't talking about that, different side channel. That gets down to the second question, where you're looking at different ways of doing root of trust. And those are really compelling. And I'm not sure if that's a thing. I think Vincent's approach, he was talking about earlier today, of code first, standard second, is probably the way to go with that. Because there's so many alternatives for that right now that I don't, my personal feeling, I don't really think that we know which one works best for a general situation. Every customer that has put investment into coming up with a different way of handling root of trust has done so for a very specific business reason. Whether those match up with everybody else's, I think it's too early to tell. But it's obvious, the way that Intel does boot guard, for instance, that essentially is a root of trust preservation. So there's a lot of interest in making sure the root of trust isn't compromised. So I think looking at something that's broader than like what we've done in the past with TPM is definitely necessary. But yeah, SMM, probably not the best way to do most of what we do with it. And I think there's a lot of concerted effort from folks from a specification and an implementation standpoint, both to try to reduce the use so we can figure out how we can wean ourselves off of it.
I love that you guys actually ended up presenting with me. All right, thanks a lot. Oh, so close.
You said with the capsules, for example, you can update individual pieces of the firmware. For example, the crypto library, if there was a patch for this, could you, because I don't think it's the shared library, you can just swap out. Can you maybe patch the crypto library on its own?
Not by itself. Like big segments of the firmware, like BIOS on its own or the ME on its own, but a driver, but not a small part, yeah.
Feature request. We can talk more later if you want. That may require reception beverages.
All right, I guess that runs up the roundup. Thank you very much again.
Thank you.